Right, this one is lesson 18 for the higher paper, and it's to do with trigonometry. Okay, trigonometry. Right, first thing to do with trigonometry is this lesson on trigonometry is only concerned with right angled triangles. Only concerned with right angled triangles. There is a subsequent lesson that we'll do where we're using trigonometry for non-right angled triangles using other kinds of things, but not today. So let's have a right angled triangle there, and first of all we need to know the names of the sides. So call that angle X. Yeah, and what trigonometry does, it not only finds a missing side, it finds unknown angles as well. So from the point of view of the angle here, this is the hypotenuse, and the hypotenuse is always the longest side. Doesn't matter where you are. Yeah, if I was up there, angle Y, it would still be the longest side. But here, from X, if I look across the triangle, this is what we call the opposite side. And this one, it will be the adjacent side. Now, if the triangle is up the other end, or the angle that we're worried about, don't worry about these angles, angle Y, then this again is the hypotenuse, the longest side, and this one down here is the opposite. And this one here is the adjacent. So the hypotenuse always stays in the same place, but the adjacent and the opposite sides can swap around depending on where you are, which angle you're looking at. Right, so we've got that. Now once you know what they are, you need to remember this for trigonometry. This is SOHCAHTOA. The word SOHCAHTOA. Now this can be split up into three different parts, and it will give you an equation or a formula to find the unknown side or angle regardless of what you know. If you know the adjacent and an angle, you can find the opposite and the hypotenuse. If you know an angle and the hypotenuse, you can find the adjacent and opposite. It doesn't matter. As long as you know two things, this will find you the third. So always write that down to remind yourselves. What does all this stand for? Well, the S stands for sine, which I will abbreviate to sin, because that's what's on the calculator. This is cos, which is cosine, and this is tan, which is tangent. Yeah, so you've got these three things. So you've got sine, cos, and tan. Now, basically, what these are is sine is, if we have an angle here, sine is how far across this point is. Cos is how far up that point is, and tangent is the gradient. Yeah, but we don't really need to know that in order to do all this stuff. So what's the OH, AH, and OA? Well, look, O for opposite, H for hypotenuse, and A for adjacent. That's what it means. So these three different formulas are written as such. Sine, and I'll call the angle X, equals the opposite divided by the hypotenuse. Cosine, the angle X, equals the adjacent divided by the hypotenuse. And tangent of the angle X equals the opposite divided by the adjacent. So you can see no matter which one we need, there is always one of these that will help us. Yeah. If we need to find either the opposite or the hypotenuse, this one will help us. Adjacent or hypotenuse, and opposite and adjacent. one of these will find it. Depending on which angle in the triangle. There's always one to find. So let's have a go at one, shall we? Right. So let's have a go at trying to do this. So some of these require an extra little bit in manipulating the formula. So what we're going to do is going to have 30 and we're going to have 12. And what do we want to find? We want to find the hypotenuse. Let's find the hypotenuse. Yeah. So label things up. Hypotenuse, I'll call that x to start off with. Oops. Yeah, it makes more sense here. Because that's what it would be in a question, x. So we'll label them up. So this is the opposite. This is the hypotenuse. Now there's no point labeling the adjacent down the bottom because we don't know it and they haven't asked us to find it, so we're not interested in that. So next we write so, ka, toa, yeah, and we want something with the opposite and the hypotenuse in. Opposite and hypotenuse is this one. Sine x equals the opposite divided by the hypotenuse. So sine 30 equals opposite is 12, hypotenuse is that, the x, that's what we don't know. When you have these little triangular type equations here, we need to know what x is, so we need to get x up on the other side of the equal sign on its own. So the easiest thing to do with this is just to swap these two around so that you get x equals 12 divided by sine 30. Now, you can go the long-winded one by multiplying both sides by x and then dividing both sides by sine 30, but this gets you straight there. Just remember, when you get that triangular shape, you can swap them. So x is 12 divided by sine 30. So you need a calculator. You won't be asked to do this without 12 divided by the sine button. It comes up in open brackets. Stick 30 in there and it equals 24. So the length of the hypotenuse is 24 something or others, which is good because a little test is x must be at least bigger than 12 because it's the longer side. That's fine. So let's have another one. So we've got this. I'll try and do an example of every different combination. So we've got 40 degrees there and we've got x over there and that's the hypotenuse is 25. So label them up. Opposite, hypotenuse. Don't need the adjacent at the moment. So so, ka, toa. So we need opposite and hypotenuse. Opposite and hypotenuse is this one again, yeah? So we're not finding the hypotenuse, we're finding the opposite this time. So sine 40 equals the opposite, which is x, divided by the hypotenuse, which is 25. So multiply both sides by 25, so we get 25 times sine 40 equals x. Now, good practice is to put this 25 before the sine 40, not after it, because otherwise the calculator may get confused and try to work out what the sine of 40 times 25 is. So do that on the calculator. So on the calculator I am pressing 25 times the sine button, open brackets, and 40 in there, and it gives me 16.07 more or less to two decimal places. 16.07. 16.07. Who would have thought? Who would have thought? Yeah. Okay, we need more, don't we? We need more. Let's have another combination. Use something that doesn't use sine. So there we go. So we've got 22. We got x and we'll have 20 degrees in there. So from the 20, this is the adjacent, yeah, and this is the hypotenuse. So so, ka, toa. We need adjacent and hypotenuse, which is this one. So cos 20 equals adjacent is x, hypotenuse is 22. So 22 times cos 20 equals x. So x will equal, let's do that. These are really easy once you get the hang of them. 22 times cos 20, 20.67. 20.67, I like the idea of that. 20.67, and this is an ideal kind of question where the examiner will ask you to possibly round to significant figures or decimal places, so bear that in mind. So let's have another go. Can't get enough of these are great. So 1, 2, 3, here we go, do that, and we'll have x, and we'll have 30, and we'll have 21 in there. So what are we finding? So this is the hypotenuse, this is the adjacent, so ka, toa. So we need adjacent, our hypotenuse is this one again. So cos 21 equals adjacent 30 divided by x. Let's do this little swap round bit because x is on the bottom. So x equals 30 divided by cos 21, which equals the following. Get the calculator out. 30 divided by cos 21, which equals 32.13. 32.13. 32.13 centimeters, meters, inches, miles, whatever it might be. Okay, so got another one. Right. This time, let's have the angle at the top. And we'll have x, and we'll have 20. Right, so this is the adjacent, and this is the opposite. So, ka, toa. We need one with the adjacent and the opposite in, that is that one. And therefore, tan 34 equals opposite divided by the adjacent. Swap them round. X equals 20 divided by tan 34, which equals 20 divided by tan 34 equals 29.65. 29.65 or 29.7 to 1 decimal place, that sort of thing. Right, keep going, we've got lots of these. We haven't found an angle yet, so should we find an angle? Yeah. So angle X, that's 10, that's 15. Okay, so label them up. We've got the opposite, and we've got the hypotenuse. So, hang on. So, ka, toa. We want opposite and hypotenuse, this one, yeah? So sine x equals opposite over 10 over 15. Right. Now, there's no need to do this in 2 bits. All we need to do is go sine, and then it comes up in your calculator as this one. 10 divided by 15 Right. Now, what we're doing here, if I don't like 10 divided by 15 anyway. So instead of finding the sine of an angle to equal a sine of a known angle to equal a number, what we're doing here is we're using the number to find the angle. So we need to use the shift sign. So when you go from a numerical value to an angle that is unknown, you need to go shift, and to the little yellow writing just above the sign button. So shift sign, and that comes up with on your calculator sine minus 1, like that. And then you just put 10 divided by 15 in the calculator. I don't think you need the bracket at the end. So 10 divided by 15, and that will come up as 48. 48. So can we go down a little bit? 48.81 degrees. Yeah. So when you're going for a number to an angle, you do the shift sign. When you're going from the angle to the number, you just press the sign button. So it's just a little bit different, just a little bit different. I didn't like that 10 divided by 15 because it come up with it. I could see where that was heading to like a recurring decimal, so I didn't like that. So let's find this one. So, and this is 28, and this is 46. Let's hope this doesn't do a recurring. Let's label them up. So this is the hypotenuse, this is the adjacent, and we write so, ca, toa. And so we want the adjacent hypotenuse, so this time it's cosine. So we're doing cosine x equals 28 divided by 46. So we're going from a number to an angle. So we do the following. We do shift cosine. Yeah. So you shift cosine, so you get on your display that, and then just do 28 divided by 46, and that should give you the answer. Shift cosine 28 divided by 46 is 52.5. 52.5 degrees. Yeah. And one more just to round this up, see where we go with this. We haven't used tangent, have we? Oh, never mind. Come on, let's do a tangent one. So we're going to find x, and tangent is adjacent and opposite. So we need a number over there and a number down there. There's the right angle. So this is the opposite. This is the adjacent. So that's what we're interested in. So so, ka, toa, soka, right, tangent, opposite and adjacent, this one. So tan x equals opposite divided by the adjacent is 50. So again, we do shift tan 40 divided by 50 equals 38.66 degrees. Yeah. Okay, so that's 2D. Oh, no, it's not 2D, is it? It is 2D, but it's not 2D trigonometry. 3D trigonometry, that would be complicated. So that is, where's my little cursor? That's the end of that one. So let's come up there, and I'll see you in the next one.